And our goal is always to reach cost parity after setting up the supply chain and industrializing. So, of course, there will be an investment, but you have to hold that investment against the risk you have in 5 to 10 years if you haven't made it.
My name is Patrick Hypscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models. Recycling of plastics that is part of products may sound challenging, but it can be done. Companies are doing that. And these are the stories we want to share with you. Welcome to our series on recycled plastics for premium brands. This series is sponsored by HolyPoly. HolyPoly turns untapped waste into reliable industrial raw material sources. HolyPoly has done that already for brands like Mattel, Lego, Lamy, and the brands you're hearing in this series. Let's zoom in on this episode. The decisions we're taking today on product design, material choice, or procurement options, these decisions have consequences in the future. Wouldn't it be handy to travel into the future, look at the consequences of our decisions, and then come back and maybe alter some of our decisions? Sounds like the movie Back into the Future? Exactly. This is the starting point of my conversation with Fridolin. We met at K 2025, world's #1 trade fair for plastics and rubber. There, HolyPoly got the DeLorean DMC-12 from the movie Back to the Future. We used that car to look into the future of plastics recycling. But before we start, I have an offer for you. If you want to get the actionable one-pager about this conversation, please sign up to the Circularity FM newsletter. You can find it at www.circularity.fm. It's time warp into the future. Whoa! Woohoo! Frido, you've seen the future of plastics recycling.
I have many times a day.
How does it look like? Tell us.
Well, it's kind of twofold. On the one hand, it's dire because there's a huge shortage in the availability of recycled plastics.
That's bad.
That's bad. It's really bad. There's huge price increases and there's just lacking raw materials. They're stopping productions at time. This will even out over time, but it's hard hits to the manufacturing base of many goods that are made of plastics that now needs to contain certain recycled content and didn't get a hold of it because it wasn't the recycling capacity wasn't available. Right. On the other hand, it was also quite impressive that there were some companies, some partnerships, really, some new supply chains that did it quite differently, that used the waste that is available in our world and built impressive and especially very efficient supply chain from that and had that availability. But it was really like a black and white situation. Those who were relying on commodity markets had a problem because there was a supply shortage, a severe one.
And how did that happen? Right now we're speaking towards the end of 2025.
Mm-hmm.
You looked into the future, travel to 2035.
Mm-hmm.
Right now, I don't experience a shortage when it comes to recycled materials. So what changed?
Well, primarily regulations changed.
Mm-hmm.
So mandatory recycled content targets that we already have for packaging in the European Union, also in some other markets around the world, expanded to other applications, for example, vehicles, also electrical appliances, and also other product groups. Why did that change, or why were these regulations introduced? Because it's the most energy efficient, the most climate effective tool when dealing with plastics to introduce recycled content. And on the other hand, waste is not used. So 95% today in 2025 of engineering plastics is long-standing or like durable applications, demanding polymers are wasted. So they are incinerated or they're landfilled. And therefore there's a huge opportunity, and the European Union and also other nation states and regulating bodies around the world want to change that by making sure there is enough demand, because that's what's lacking today, because we're very cheap virgin plastics. And of course we have a system, the entire value chain, from the basic design to the tiniest optimization in any type of process is of course completely designed for and practiced for virgin plastics. It's a completely linear economy, like I said. So there's a lot of change that has to happen. It's quite cheap to stay in the status quo. So yeah, that's kind of the two realities, and I'm switching back and forth all day and taking visitors with me in this nice time machine. That works really well.
Okay, cool. Yeah. Next to the regulation. So why is it flashing? You know, no,
Because I have a button
this
for that.
is like this is the true DeLorean time machine, all fully equipped. So you mentioned there's a lack of capacity in the future. I mean, already now, but then increasing demand, and that the result of that is increasing prices.
Yes, and also supply shortages, stopping production, or then going back to virgin plastics, which means penalties. That's what will happen. So it's a mess. Yeah.
Okay. And there are certainly some winners and losers.
Yes.
How do the losers look like? Describe them for us.
Well, like I said, they remain with the standard commodity purchasing model that is prevalent today. So that means you're incentivized as a purchaser to lower cost by X in the next period of time. So that's usually quarter, sometimes even month. You want to get down with prices or optimize under market conditions, and sometimes of course it also goes up, and you have then these index prices, and that works for now, but has been pretty much working for the past decades. There were some outliers, like when COVID happened, or when like COVID. You remember? That's when we founded our company. It was the most normal thing to never meet. And also you had the chip crisis or the blockage of the Suez Canal at some point. So there were these hits, but they're so long ago, and now it works. And why, like, it's a topic, like supply chain resilience is a topic, but not a priority topic, I would say. So they kept relying on the classic purchasing model, which is commodity markets, and said, well, I can get what I want today. They're gonna provide it to me tomorrow if it's mandatory. Why should I care? It's the same as happening with we have the mandatory content targets for packaging ready to the European Union, but it's for 2028 or 2030. So there's still a few years time. Right now, nobody cares because we still have time. You can purchase in 2028. And what this leads to, and that's what seems to be not in scope of the classic purchasing agent, is that recycling capacity today is decreasing. We're losing probably 1 million tons of recyclate capacity this year in Europe, while at the same time we should be doubling it. And that will lead, so demand will increase, like you said. That will lead to disaster. And those companies who said, well, let's see what regulation will bring. Oh, okay, there's still a few years. Maybe we can just lobby it away when it's there. Then we can say we don't have access, take away the target. The targets, like I said, are necessary to reach the climate transition. So that's not really an option. It will happen. And yeah, it's lack of foresight, I would say.
And let's look at the winners. What did they do?
Well, the opposite. They expanded their horizon or scope to longer time frames and increased complexity, which means looking at those supply chains that are not yet existing, because right now that's just a pile of waste. You don't even know where it is, how it is, if it's toxic. You have no idea. You just see a pile of waste, end of life vehicles, packaging, e-waste, you name it. All products reach end of life at some point, and to make that into what you can use as a raw material for volume production for premium products, it's a long road to go, let's say. And you have to appreciate that and deal with it and invest in it. And there were quite a few companies who did that, and they were the winners in the end.
Okay. So correct me if I'm wrong, but what I understood is basically that there will be a regulatory change or increase that will ultimately lead to a increased demand for recycled plastics, and this will meet a shortage in capacity, and therefore we have a price increase and maybe even absolute shortages for some products. And this is pure economic, let's say, rationale behind that.
Yes, of course, before that, we have a sustainability rationale that leads to those regulations, because like I said, it's a hugely impactful climate impact lever. And all of the companies doing their CSRD or generally their non-financial reporting, they know this. It's in the double material. If you're a company that uses a lot of plastics, switching to recycled is one of the biggest impacts you can have. And of course, that has also a financial impact because there will be a price on carbon. And that, will make a difference.
Okay. We already talked about, or we talked about recycling, but there is mechanical recycling and chemical recycling. Right now, they seemed a bit, seems to be a fight going on. Who was the winner?
I'm still eating popcorn, looking at it. Sometimes going for the one guy, sometimes for the other. Just keeping everybody confused. No, it's basic thermodynamics. If you can solve it mechanically, it will always be more energy efficient and therefore more cost efficient. The image that I have in mind, and it comes from Thomas Müller-Kirschbaum, who set up the sustainability strategy of Henkel, and he's on our board, and he has this nice long-term vision, let's say, which is a staircase. Each step of the staircase is a mechanical recycling cycle. Is one step. Why is it a step? It's a downward staircase because quality is decreasing. You have contaminations from use. You have degradation. You can't do it forever. You can do it many times. Definitely beyond 10 in some cases, but it's finite. It's definitely finite. It's also highly dependent on what you make of it after this cycle. It's always different requirements to a product. But it will be a staircase down. And in each step, you lose some of the material because there's process loss. But at the end, you need an elevator to go back up quality-wise, and that's chemical recycling. But in that elevator, first of all, it's more expensive than each of the staircase steps, so you only want to take it when you're at the bottom. And in that elevator, you lose even more of process loss. And all of this lost material, and also probably will, as a global economy, continue to grow for quite some time. So we will even need more than the installed base. It will not be able to sustain itself. All of the growth and the process loss replacement has to come from bio-based sources. That's the long-term vision. But like I said, it's the first step of the staircase we have to prioritize right now. That doesn't mean that the other elements aren't important for a fully circular, climate neutral economy by 2050. Absolutely. But what we're looking at is the next 10 years. Of course, we have to do research. We have to understand what are really the types of chemical recycling, the types of also bio-based plastics that make sense, that can be fit into the entire picture of a sustainable economy of the future. Well, so we have to keep working on it. But I don't think it's the next 10 years where we should be scaling it. Other than special requirements from the direct food contact. That's one application where it makes sense, but also only in some cases. So, and also chemical recycling is not chemical recycling. There's a large scale of technologies. Some are energy efficient, more energy efficient than others. So in the end, it will be an orchestra playing together, and we will need all solutions. But right now, we have to work on the the messy part, which is just collection, sortation, and then keeping quality intact anyways, because that's possible. It's just messy. It's a huge change in perspective and approaching it, and a huge also gap in trust, I guess, that we have to overcome with especially the OEMs who do the procurement, who think about quality and who think, well, this is waste.
Yeah.
This is not going to work.
Yeah. Okay. Let's stick to that messiness and the challenges. So if you first look at collection, so what are the main hurdles and how to overcome them?
Well, it's really different per product, per vertical, per material, per region. All of that is, of course, naturally dependent on the application and especially what is the end of life like. And first of all, it's about understanding. I'll give you an example. We just launched or published a power tool, a closed loop power tool for Bosch, and it's made from end-of-life power tools, which is a fraction, we say, in waste management. So a part of the e-waste stream that is it's collected. Even not all of it is collected. There's a lot of in the basements or in the wrong bins, but a large fraction is collected. I think it was like 70,000 tons per annum in Europe. Wow. Don't quote me on that, but order of magnitude is in the system. But if you have it mixed with all the cassette decks and mixers and the appliances and whatnot, all the small electrical appliances are one big chunk and shredded together, then the type of plastic in the housings of power tools is such a small part compared to the rest that it's irrelevant, or it's not being recycled, so it's lost. But that doesn't have to be if we sort out the power tool before the overall shredder. And then we can do a dedicated process for that. And that's what we did. And that was the easy part to figure out, that it's there and we can separate it here before they're shredded. But then the question was, is there substances of concern? So chemicals that we used to put into our products 20, 30 years ago that we're not allowed to do anymore. And rightfully so, because they're toxic. And nobody had any clue, which means from a risk-based perspective, you would say it's not possible. But what did we do? In a venture climbing partnership with Bosch many years ago, we, and also a compounder, MKV is their name, in a good partnership, we kind of reverse engineered the waste stream. So we took 7,000 tools, collected several 100,000 data points, and we were able to model it to identify where can we do what sortation step in the end to remove everything that is a concern. And we can reliably do that now, and we're industrializing it, and we have found a solution. But the first step was understanding, and really it's a completely new field for engineering and for quality then down the line. And of course, before that, the question is the user, what's happening there at the end of life moment, and how can we get them to separate into our collection? That's a entirely differently but very important field of complexity, because the earlier we can access the waste, and the user will be the earliest possible stage, because that's where it becomes waste, where they want to get rid of it. That's the moment waste is created. If we can access it there, and if we can make it just the new normal for them, like we have a good adoption of the deposit bottle scheme in Germany, the same type of standard procedure. And we approach this, we call this reverse marketing. We approach this in a way where we think of the status quo, which is the attic or the standard bin where it's lost then, as the competition. And we, like with the marketing and sales mindset, we want to get the better conversion, the better awareness, that in the end, the higher volume funnel into our program than the status quo. And like that, you can achieve a lot if you get it right. But of course, it's quite a complex new part of operations and strategy and design.
So what you're saying is basically, first you need to understand the end of life journey of your product. Then in the second step, you need to come up with a convincing proposition that at some point in this end of life journey, you get access in an economically viable way.
Absolutely.
And then you need to analyze what you got back in terms of what's the material composition, and how can I use that again for new products.
And then you have to develop a process, and then you have to develop a formulation.
Yeah.
That's really like the final
Not
step.
easy.
The funny thing is the basic processes are really easy. It's take, shred, sort, melt at 200 degrees. It's not rocket science.
Yeah.
What goes into a new car is way more complex than that. But the execution and the lack of knowledge that's existing, and the lack of experience, and like it's a huge change of business practice, not by one entity but by thousands, potentially millions if you take the users into account. And that's what makes it complex. It's not that the process is not complex.
Yeah. And basically, I mean, the elephant here in the DeLorean is cost.
Yes.
I mean, why do companies avoid starting it? Because they're afraid of additional costs in this process. So how to make that a competitive option?
Yes. First of all, we focus on engineering polymers. That means that the benchmark you compete against is higher than for plastics like polypropylene or polyethylene, which is like the really the massive fly that are mostly in packaging. We work with more engineering materials is what they're called. So polyamide, for example, it starts with ABS. I don't know if you know about the materials, but it's just instead of €1, they cost €2.50 or €3 per kilogram as of today. And our goal is always to reach cost parity after setting up the supply chain and industrializing it. So of course there will be an investment, but you have to hold that investment against the risk you have in 5 to 10 years if you haven't read it. That's the idea of the winners and losers. Of course, you will have to invest up front, but it's not going to work if the material is much more expensive. Of course not. So that's the target that we have, and what we see from all the projects that we do, work with many major brands globally, mostly European. We can achieve cost parity because once you have the volume, and in order to get the volume, you need the demand behind it, and we organize that. And of course, the development upstream to get to being able to supply. But once you have all of that figured out, and then you reach a volume of between 500 and 2,000 annual tons, you can set up a dedicated line that does just that. And with that, you can get to cost parity, sometimes even below by engineering progress.
Nice.
And at the same time, you are saving 60% up to in the power tool example where we can just make the new housing with 100% old housings. That's like really the far end. That's probably not what we'll do in the volume production, but there we get to 90% carbon emission savings. So between 60 and 90% carbon emission savings
compared to virgin.
Yeah. Let's make it 60 to 80 to be a bit more conservative, but that's what you save. And that means between, let's say, 1.5 and 3.5 tons per ton that you save. And 1 ton will be worth, by the end of the decade, at least €100, probably more like 150 or 200. And the thing is, right now, this carbon price is not visible, or it doesn't translate into the price of virgin materials because there is no mechanism in place, especially for imports, that really transfers it there. But we need carbon pricing. Like the overall assumption is that we're fucked from a climate perspective, and we have to get it under control. So we will need regulation, and 2 major parts of regulations will be the mandatory targets and carbon pricing. So carbon pricing will be included, and it will also be included in the virgin materials cost. And if we reach cost parity to today, which is without carbon pricing on the virgin side, we won't have increased. We'll have a bit, but we're only considering the delta, which is the tons that I said, the 60 to 80%, which means that we save 1.5 to X times €150. So that's a savings per ton net that we have once all of this has been introduced. And that's the business case in the end for all these material development own streams projects, that we compare the investment upfront that is there.
Yeah.
Also the initial tons, of course, there's a ramp up curve. And before we reach the capacity, it will be more costly per ton. Compare that to the savings of the future of carbon emissions. And like that is not hard really, because right now there's many low-hanging fruit. I wouldn't call it low-hanging fruits, but like there's still quite a stretch to get there. But like I said, 95% of waste, and let's make it 90% of waste, is not used.
Yeah.
It's still out there.
Yeah.
You can
For free.
dismantle more or less for free.
Yeah, well,
But yeah,
I mean,
but
you
it's-
need to get access, but
Yes,
the material.
but it's a fact. They pay, the entity that has it right now pays for getting rid of
Yeah.
it. And that cost will also increase over time. But yeah, it's possible to do that, and we always get to a price of between 2 and 3 euros per kilogram, which is cost parity, like I said.
I want to come back to two aspects. One is about procurement and the other one about product development. So you mentioned it's about like ramping up this supply and building up also the ecosystem. What does it mean for procurement specialists?
It means increased complexity, and it means embracing increased complexity. And I'm still trying to understand them, to be honest, but I think the more complex one is the time dimension. But also, of course, the entire supply chain is more complex. But I think that's easier to wrap your head around once you've gotten in touch and you've seen the waste streams and you've had a few pilot projects, and you understand there is other classes of quality, other risks, other price dynamics, other upstream value chains, less data available that you can just look up. But I think it's easier to understand, but to understand that you have to invest now to get something at some point in the future that still has uncertainties connected to it. The strategic part, of course, the strategic procurement, and it's different from organization to organization. Some are quite advanced, but in general, I think the long-term perspective on procurement is, I think, the worst blockage, or the hardest thing to change for them. The way we do it is to, of course, include procurement in all discussions, but also include many other stakeholders who have a different perspective. And like that, it's possible. And then in the end, it's not the direct procurement person deciding about these initial development projects, right? It's made from our parking.
And the other aspect is about product development, because you also mentioned before, you have this mechanical recycling staircase, and at the same time, you do have performance requirements for the products. So how to deal with this familiar but also new material in your product and material composition?
Yeah. There is so much more that is possible than what people expect. That's, again, really an educational problem at its core. You have to start trusting that quality can be achieved from waste. If there is people or entities dealing with it with expertise and with diligent processes, they can't do magic, of course. There will be degradation in each step. It's not everything is like the classic virgin material is, they call it natural. So you can color it to any color. That's of course not possible if it already has a color. The pigment is in there. Okay. Limited colors. Stuff like that. There is limits. But the general level you can achieve in terms of quality is so much higher than what is anticipated by those people who have not, who would just see this mess, the pile of waste, and think, yuck. And where it really becomes most clear is when you do closed loop project, which means you make something from the materials, which is the same application than what you took it from. And the fantastic thing about plastics is that they're very durable and that they can be tailored to the application. And that tailoring has happened to the very application. Again, the power tool example is a perfect example for that. It's a material that has been chosen by Bosch with all the requirements to be a housing of a power tool. And we take that, and not only by Bosch, but also by their competitors. They all have high standards. It's always across the industry. They also use the same materials from the same suppliers in same, even colors.
Really?
Yes. So it has been made for this application. If we can manage to get a hold of this application, so get a narrow feedstock in, then we can usually apply it for the same application again. And in the Power Tools case, I mentioned this earlier as well, I think we can go 100%. So we even meet the green color of Bosch because they are the highest share in the waste stream, and the others stole their color, I guess. But we can really apply it 100%. That's usually we go below that then in volume application, but you can make a lot of it because it's so durable. And even if you go crisscross from application to application, stream to stream, there is so much more possible if you create the new quality classes and really focus on getting it done.
Yeah. You touched upon many fields that you need to build up and change. If I, as a company, want to start looking into that, where do I start?
I think most companies have done something in the field now, where at least they have some sort of sustainability strategy. But I guess in the current climate, it feels like maybe that's not a priority anymore. Maybe we can put this on hold. Maybe this doesn't work at all. Anyway, it can never work. Or that if you look, even if you're ambitious, if you look at what has to be achieved, the long journey that still has to be gone, like where you're still bad at in comparison to where you have to get, it might all lead to, loss of momentum.
But you can basically ignore that because, as we said earlier, it's about access to material, no matter your specific sustainability strategy.
Yes, absolutely. But what I want to get at is look at what you already have and just keep building, appreciate where you still have a long way to go, but keep building, don't stop, keep going. If there is setbacks, keep going anyways, because you have to go there anyway, the hard way or the easy way. You have to get there. I think that's really the most important thing. And one thing that we figured, of course, you need a business case in it. And one thing that we figured, if you do the reverse marketing thing, if you do a new direct connection to your customer at end of life, you provide them with a take back solution or a buyback scheme or whatever. That's a new touch point in a place where, in a void, I would rather say, where no other competitor has a relationship to the customer. And you can leverage that for core business effects. And that's something you can do quite early in the journey, even though you still need years to develop XYZ. But if you understand that you have a new relationship, an extended customer journey that you can use, that's something you can use to gain market share, to gain overall perception of your brand and so on. You can make this case even in hard times like this and increase momentum. It's all about momentum. It's a pipeline, a journey. We need to keep up and increase the momentum.
Are you actually saying that the circular economy professionals doing the salespeople's job?
Sometimes we do everybody's people's jobs, right? But yeah, but I think that the core thing here is, I think a lot of the circular economy, like those companies who can show progress, they have embraced that, is that, yes, I have to care about your job and their job and their job and their job. Yes, because we want to get it to work and we can't stick to our silo and wait for somebody else to do something. And that, of course, means increased complexity, and embrace this complexity, embrace the waste, embrace the complexity, and find the joy in it, find the right people who can find joy in it, I guess. Yeah. And then the gold is lying on the streets.
Yeah. Nice. And part of the truth is, right now it looks like complexity, but once you solved it, it's easy peasy. Yeah,
absolutely. Compare this to a car manufacturing.
Yeah. We can even time warp by now. Frido, last question. Not everyone had the opportunity to look into the future. So if they want to help, how can they reach you?
Just visit our website at holypoly.co and send me an email or book a call, and then we will see where we might be able to help.
Okay.
Would be great.
Wonderful. This was the first episode in our series on recycled plastics for premium brands. In the next episode, we will hear from Vorwerk, how they organized internal alignment to work on recycling for plastics. Let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination. My name is Patrick Hypscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.
Should we go back to the future?
Yeah, let's go back.
To what time? Maybe in the morning.
In the morning, yeah. In the morning is good.
Okay, let's go.
It's happening again.
Ich weiß nicht, ob der Witz nochmal lustig ist.
We're doing a podcast recording.